Okay, here we go into unit rates. I'm sorry, just rates and proportional relationships. That's what we're doing in math today. And I know what you're asking. You're asking what is a proportional relationship? Well, it's interesting because last week when we did pizza math, we were really looking at some proportional relationships. If you've got one pizza cut into 4 pieces and another pizza cut into 8 pieces, and let's say you've got 1/4 left, so one piece out of that pizza that was only cut into fourth, and 2 pieces of that pizza cut into eighths, then 2/8 and 1/4 are the same quantity. So that would be a proportional relationship because you could very easily turn 1/4 into 2/8 by just cutting another piece. So, but I want to show you a little bit more. You're going to be going through all of this today, watching the videos, doing the practice. Try to get as much done as you possibly can. You should be able to get it all done within 90 minutes. If you have any trouble with that, please, please, please let me know. But I just want to go over proportional relationships a little bit. Now, in plain English, a proportional relationship is simply a relationship between two equivalent ratios. So, 2/8 and 1/4 would be two equivalent ratios because they have the same exact quantity. So the 3 ways to determine if proportional relationships exist. Verify that a given proportion is true. So 4/12 and 9/27. Okay, they're proportional because you could, um, you could reduce them both to 1/3. All right, so 4 divided by 1 is 1. I'm sorry, 4 divided by 4 can turn to 1, and 12 divided by 4 would be 3. Okay? Same with 9 can turn to 1, and then 27 divided by 9 would be 3. All right, so both of these can become 1/3. That means they are proportional in their relationship. Does the data displayed in the table show a proportional relationship? Okay, let's look at this. You always want to start at the top and just see how these numbers go and see if there's anything in these numbers that are repeating. Okay, so we find that something is 2 and 1. 1 is half of 2. 4 and 2. 2 is half of 4. 6 and 3. 3 is half of 6. 8 and 4. 4 is half of 8. 10 and 5. 5 is half of 10. So basically, if you wanted to put divided by 2 all the way down here, you would see what it is that is making all of these equivalent. All right, that would be the constant. The proportional constant would be divided by 2, or if you're going the other way, times 2. All right, 2 would be the constant. Again, getting into graphing and trying to figure out if the data displayed in a coordinate graph shows a proportional relationship, you always want to look for right here. If that line goes through the origin point of that quadrant, then you are dealing with a proportional relationship if it's a straight line. Okay, now if it comes through here and goes over there, it's still a straight line, but it's not a proportional relationship. So that's something to look for. Again, this would be proportional. Remember, half whole, half whole, half whole, half whole, half whole. That's what this would look like. Okay, this would look like in graph form. It would look like that. Okay, and it goes through the origin point, so you know it is a truly proportional relationship. So let's look through this. Okay, does this table show a proportional relationship? Well, let's think about it. What has to happen to 3 to get to 9? You have to multiply by 3. What happens to happen to 1 to get to 3? You have to multiply by 3. What happens to 2 to get to 6? You have to multiply by 3. What happens to 8 to get 24? You got to multiply by 3. So it is true. All of these are equivalent. This is a proportional relationship, and the constant would be 3. Okay, divided or multiplied by. Now let's see. 1 times 5 is 5. 5 times 5 is 25. 3 times 5 is 15. And 7 times 5 is 35. Which one of these doesn't belong here? It's going to be this one. Now, if this said 15, this would be a proportional relationship, but it does not. So the way they wrote that, all of these things are equal except this one. So since all of them are not equivalent, this table is not a proportional relationship. Okay, so I'm going to go through here. This is an example of a graph that is not a proportional relationship because it does not go through the origin point. So whenever you see this, it's very easy to tell. And just looking at the numbers too, there's no constant, proportional constant that would make 2 to 4, 4 to 5, 6 to 6. There's really nothing that you could put between there that would be right every time. So this would not be a proportional relationship. So go ahead and start on the link that I gave to you, rates and proportional relationships. I hope I gave you a nice little introduction. Of course, the Khan Academy videos will go more in depth and help you understand and flesh that out a little bit more. Do as much as you possibly can. Hopefully, you can finish it today. And if not, maybe you can take a little time to finish it tomorrow or on Friday. So, happy Tuesday, and I will talk to you later.